Okay, now we're going to do the domain of the log function. Remember, in the graph of a log function, if we look at the graph of log function, it runs along the y-axis and goes off to the right. So the domain consists of positive real numbers. So whatever you're evaluating the log at, the argument of the log has to be greater than 0. So for example, on this first one, if we're looking at log base 3 of 5x minus 1, this 5x minus 1 has to be greater than 0. Otherwise, we can't evaluate the log because it's not in the domain. So 5x minus 1 has to be greater than 0. Just solve for x by adding 1 and dividing by 5. So the domain of this function is all the x's in the set where we have 1/5, not including 1/5, all the way to infinity. On the second one here, if we have log base 4 of this quadratic again has to be greater than 0. So for the values of 2x squared plus 3x minus 9 being greater than 0, we factor this. It would be 2x minus 3 times x plus 3. If you think about the graph of this, it would have the zeros at positive 1.5 and negative 3. This is a quadratic that's opening up, so these two values are where it would be equal to 0, which is not what we want. We want them to be greater than 0. And the quadratic goes through those 2 points, opening up. So the places where this is greater than 0 is over here to the left of negative 3 and to the right of 1.5. So the domain would be all of the x values going from negative infinity all the way to negative 3, not including it, and then also from 1.5 all the way to infinity. If we're looking at this next one, we have a rational expression where we want that rational expression again to be greater than 0. So there's two critical values that you're looking at. The 0 of this function happens when x equals 4, and a vertical asymptote happens at x equals 2. So those are two critical values you want to look at. When x equals 2 and 4, that would be equal to 0 and not equal to at all because it makes the denominator equal to 0. So you test some values in these three interval locations. So if I plug in the point of 0, I get a negative over a positive. That's a negative. If I plug in a point at 3, that would be a negative number over a negative number, which would be positive. And if I plug in the number 5, I would get 5 minus 4 is a positive number, 2 minus 5 is a negative number, a positive divided by a negative is negative. And I want the values where this function is greater than 0. Those are all the values in between 2 and 4. So those are the x values from 2 to 4, not including either one of those points. If we look at this last one, we want that value of the square root of 3 minus 4x to be greater than 0 again. So if we square both sides, that would be 3 minus 4x is greater than 0. We want to solve for x, so we're going to subtract 3 to the other side, and then divide by negative 4. That makes positive 3/4. Also, when you divide by a negative, the inequality sign will flip around. So this is going to happen with the values of x in the domain are going to be everywhere from negative infinity all the way up to positive 3/4, but not including it. So if you look at the values of this function, you actually plug them in. If you plug in 3/4, you get 3 minus 4 times 3/4. That would be 3 minus 3 would be square root of 0. So that's the point where log would be equal to 0. Log of 0 would not happen, so we want not including that point, but all the values below it. It's like the first point where it equals 0. So if we pick a point less than 3/4, like let's say we pick 0, and we plug that in, you'd have 3 minus 0, that would equal a positive number. That would be good to go, and that would be one of the numbers that you could plug into the domain. So that is in between negative infinity and 3/4.